how we doing there? Now, today we're talking about section 9.3, day 2 notes. All right, and we're going to talk about holes in our graphs. Now you're probably saying, what? Holes? Well, no, so this is my rational equation I'm dealing with. All right, so let's factor the top and bottom and just see what happens. So on top here, I have a difference of 2 squares, so I have x plus 3, x minus 3, all over my denominator, which is x plus 3. Now, if you notice here, my x plus 3's cancel, and I'm left with the resulting equation, y equals x minus 3. Now, me and you know what kind of graph is that. That's a linear function. So if I wanted to graph that, I graph my y-intercept, and my slope is up 1 over 1. Up 1 over 1, up 1 over 1. So that's the graph I'm dealing with. Now, when looking at this, you would never thought that was a straight line. Now, when we talk about vertical asymptotes, all right, and horizontal asymptotes, think about this. What's an asymptote of a line? All right, in this case, there's none. And the reason being is that in this simplified function, there's nothing in the denominator. All right, a vertical asymptote is usually what makes the denominator 0. But in this case, there absolutely isn't a denominator, so it's none. So what that only occurs when there's nothing in the denominator. All right, your horizontal asymptote is also none. Again, it kind of makes sense. It's linear, right? This thing spans forever that way and that way. It never... There's no horizontal or vertical asymptote to stop it or make it curl off, sorry. So, now we have a new component here, which is holes. Now, the holes is, when this denominator cancels out, what would have made it 0? All right, and what it's saying, so the hole would have been at, think of what your vertical asymptote would have been up here. All right, so it's whatever cancels out is your hole. In this case, negative 3 would cause that to be 0. So whatever cancels out is your hole, and we'll sum that up in a minute here. Okay, now, so your domain right now is x is all real numbers, however, it's not negative 3. And I'll show you again what happens. Now, to find your y value of your hole, what you do is you plug it into what's left. All right, so we're going to substitute it into here. So plug into what's left. All right, so here it's x minus 3. So in this case, I would have negative 3 minus 3. So y equals negative 3 minus 3, which gives me a y value of negative 6. So actually, in this graph, at negative 3, negative 6, there's actually a hole in this graph that you cannot see. All right, now, think of your range. So what can y be? Well, y can be all real numbers except for negative 6. Now, you're probably saying to yourself, why? What? There's a hole in my graph? That makes no sense. Well, it actually stems from, if you put this in here, if you look here, all right, yx plus 3 over x minus x plus 3, sorry, and you put in negative 3, you get 0 over 0. What does that equal? Is it undefined? Is it 0? Or is it 1? Okay, these are all great questions, and you learn why in calculus. All right, there's a theorem that kind of helps us understand all that. And when you get to calculus, you'll talk about that. But that's why, because it's saying, well, what happens here? We're not sure yet. Okay, it could be any 3 of those things, so it doesn't exist. Now, if you actually go to your calculator, and now, when you go to draw your graph, now that was linear, so I used it to explain it, but when you go to draw your graph, always use your original, always use your original equation. All right? Reason being that, what if you made a mistake factoring? We don't want to plot this, and it won't show the holes in this. This will only be a linear. So let's say I have x squared minus 9 divided by x plus, I forgot my parentheses. Let's go back. x plus 3. Then graph. All right, now we want to look at where x is negative 3 and y is negative 6. So I'm going to go second, calculate, value. It says, well, what do you want x to equal? I want x to equal negative 3. Enter, and watch what happens. What's my y value? Disappeared. All right, so your calculator knows that there's a hole there. All right, your calculator knows because it will not give you a value. And if you go to your table at x equals negative 3, you're going to get an error message. All right, so that'll also tell you. So you can always check to see if your hole is correct. All right, make sense? So let's sum this real quick. If the denominator cancels out, okay, then it results in a hole. So if you factor out and the denominator cancels out in the sense that there's nothing left in the denominator, or it cancels out. Now, if anything remains in the denominator, then you have a vertical asymptote. Okay, now let's say this next example is unique because one's going to cancel out and one's going to stay in the denominator. So we're actually going to have an asymptote and a hole. Watch. Okay, but that's kind of how we sum it up. So let's factor. So the top one is GCF, it's 2x. I'm left with x plus 4. In the denominator, two numbers that multiply to positive 8, add to 6, I get x plus 2, x plus 4. So notice, something cancels in the denominator. So as soon as that cancels, one of my holes is at negative 4. Now, however, my resulting equation is still 2x over x plus 2. So I still have a resulting equation. So in that resulting equation, what's my vertical asymptote? Well, what makes the denominator equal 0? So I have x plus 2, so x equals negative 2 is a vertical asymptote. My horizontal asymptote, okay, there's an x on top and bottom, so I'm looking at these coefficients, right? So 2 over 1, or y equals 2, so that's the same as we've always been doing. Now for the hole, I'm going to put this in my simplified form. So 2 times negative 4 over negative 4 plus 2 gives me negative 8 over negative 2, so I get positive 4. Sorry, let me put that in red so it matches. Positive 4. Now let's draw a graph before we talk about domain and range. So vertical asymptote at x is negative 2. And horizontal asymptote at y is 2. All right, now as we talked about yesterday, our graphs can really, our graphs can really show up anywhere. All right. So when we type this one in, again, always type in the original equation. 2x squared. Oh, I'm going to use parentheses, my bad. 2x squared plus 8x, close parentheses, divided by, parentheses, x squared plus 6x plus 8. Now, at this point, our graphs are getting a little funky, so let's just draw quick sketches. All right, and these complicated ones, we don't necessarily need to go find points. Right now, I'm more concerned with understanding the domain and range in these holes. So my graph's in the second and fourth quadrant with a hole at negative 4, 4. So negative 4, 4. There's a hole, and your graph kind of looks like that. All right, so I'm comfortable with that. Now let's talk about domain and range. So now my domain, well, x can be all real numbers, except for x cannot be negative 2 because there's an asymptote there, so we don't cross there, and x cannot be negative 4. All right, now sometimes when you have a lot of stuff, you can put the brackets. Not necessary. I'm more concerned with the concept. Do you understand what that is? All right, then my range again now, y is all real numbers. except y cannot be 2 because there's an asymptote there, and can't be 4. Now, you can also write it like this. You don't have to write it twice, so I wanted to show you both ways. You don't have to write y cannot equal again, as long as you have a comma there. Again, that's when we put in the brackets, just because it's a lot of information. All right, so y cannot be 2 because of the asymptote, and y cannot be 4 because of the whole. All right, so whatever cancels in the denominator, that's what creates a hole in the graph. Whatever's left, we just go through our normal steps for our vertical and horizontal asymptote. In the first one, as you found, nothing was left, so there was no vertical asymptote. All right, let's go on to the back. Now, there's one more problem here. I'm going to set it up for you, factor it, and then you're on your own to finish the other information. So I'm going to actually start down here just to give myself some more room. You probably don't want to draw the arrow because you're going to have to do all the work in there. So the first thing I'm going to do here is pull out a GCF of 2. I'm left with x squared plus 5x plus 6. And factoring that, I have the two numbers that multiply to 6 and add to 5, x plus 2, x plus 3. In the denominator, that's a grouping problem. So I have an x squared times x plus 3 minus 4 times x plus 3. So I have x squared minus 4 times x plus 3. Now the x squared minus 4 can be a difference of 2 squares. So I have 2x plus 2, x plus 3. And on the bottom now I have x minus 2, x plus 2, x plus 3. So in this case my 3's are gone, my 2's are gone. That's my resulting equation. So how many holes are you going to have? 1, 2. We're going to have 2 holes in this one. Make sure to find your domain and range and draw a quick sketch. So I'm going to leave this one up to you, and I'll be checking it tomorrow. All right, see you then.